Hi there, so today we're looking at Unit 9, 9.1 sequences. Our objectives for today, to be able to recognise and continue a number sequences, to generate terms of a sequence using a term-to-term rule, and to find the missing terms in a sequence. Before we start, let's check our prior knowledge. So you need to be able to count forwards and backwards, including with negative numbers, and you need to be able to add, subtract, multiply and divide. Things that you need then, you'll need your maths book or some paper to write on, you need a pen or a pencil, and you may wish to have a calculator to help you with some of these questions if you feel you need it. Make sure you've got those before you start. Okay, so today then we're having a look at sequences. A sequence is a list of numbers in a specific order. Each number in a sequence we call a term. So here is a sequence, 4, 8, 12, 16, 20, etc. Now hopefully you'll recognise this sequence. This is our 4 times tables. So the first number in this sequence, the first term, is the number 4. 24 is the 6th term in the sequence. So when we say the word term, we're simply counting along the numbers. So 4 was our first term, 8 the second, and the third, the 4th, the 5th, the 6th, the 7th and the 8th. So when we've got a number of terms, it's simply its position in our sequence. If the terms are next to each other, they're referred to as consecutive terms. So 12 and 16 are consecutive terms. They are next to each other in our sequence. Okay, so here are some sequences then you might already know. So 2, 4, 6, 8 and 10. Hopefully you'll be able to tell me that those are our even numbers. So some of our sequences have their own special name. That's also the 2 times table or multiples of 2. 1, 3, 5, 7, 9. Those are our odd numbers. 3, 6, 9, 12, 15. Now they're the multiples of 3, our 3 times table. So we often call times tables multiples of a number as well. 5, 10, 15, 20, 25. They're the multiples of 5, the 5 times table. 1, 4, 9, 16, 25. Do you recognise that one? Those are our square numbers. 1, 3, 6, 10, 15, 21. Perhaps one you're not as familiar with. Those are the triangle numbers. And 2, 3, 5, 7, 11, 13. Those are our prime numbers. If you're not sure about any of those sequences of numbers, please, after this lesson, take the time to look those up. You'll find lots of information, easy to find on the internet, about those different numbers and their properties and how we get those types of numbers. Okay, so lots of sequences don't have their own special name, so we can describe them by describing a rule. So this sequence, we add 3 each time. So we started with 1, we added 3 and got 4. If we add 3, we get 7, we add 3, we get 10, and we can keep doing that as much as we want to. So we say the rule for this sequence from getting from one term to the next, so remember from the first term to the second term and the second to the third, the rule is add 3. So where we have a sequence that doesn't have its own special name, we can describe it by saying the rule to get from one number to the next number. So that's called the term-to-term rule, how to get from one term to the next one. So as long as I know a term and the rule, I can find the next term. So we would say, again, for this sequence, it's add 3 or plus 3. Here we've got another sequence. Just take a second, see if you can work out the next 3 terms. Okay, they're minus 8, minus 14 and minus 20. How did we get those? Well, if we look at the first term of 22 and we want to go to 16, so to get from 22 to 16 we would have to subtract 6. from 16 to 10, we'd have to subtract 6 again. And we keep moving along by subtracting 6 each time. So our sequence this time is a decreasing sequence. The numbers start big and get smaller. And the rule for this sequence is subtract 6 or minus 6. So again, we can describe the sequence by describing the rule that we've used to get from one number to the next number. So the key points so far in this lesson then, sequences where the numbers increase are called ascending sequences. Sequences like this one where the numbers decrease are descending sequences. And a sequence is a set of numbers that follows a rule. Each number in the sequence is called a term, and the term-to-term rule tells us how to get from one term to the next in a sequence, and we could use adding, subtracting, multiplying or dividing. Okay, if we're given the first term in a sequence and a rule, we can find the rest of the numbers in the sequence. We can carry on our sequence. So if the first term is 3 and the rule is plus 4, and we want the first 5 terms of the sequence, remember the first 5 terms are the first 5 numbers, it would be, now we start with our 3, that's our first term. The rule was add 4, so if I add 4 to 3, I get 7. If I add 4, I get 11. Add 4, I get 15. Add 4, I get 19. Now we were asked for the first 5 terms, so 1, 2, 3, 4, 5. I've got all the ones I need. Have a go with these. See if you can write the first 5 terms for each sequence following the rule. Try to do it on your own first if you can. If you get stuck, then you can try using your calculator. Pause the video, have a go now. Alright, so our first one then, our first term was 10 and the rule was add 3. So we should have 10, 13, 16, 19 and 22. They are our first 5 terms. For our second one, we started with 100 and our rule is subtract 5 each time. So 100, 95, 90, 85 and 80 would be the first 5. Our next one starts with a 3 and it says double. So remember, double means to times the answer by 2. So 3 doubled is 6, double 6 to get 12, double 12 to get 24 and double 24 to get 48. So remember, whatever the rule is, we do it to the last term we got to. Our next one then starts with 5 and we're multiplying by 10. So we get 5, 50, 500, 5,000, 50,000. So remember, we're taking each number times 10, times the new number by 10, times the new number by 10. And finally then we're starting on 7 and we're subtracting 2. So 7, 5, 3, 1 and minus 1. So once we get past 0, we go into our negative number. So don't think that the sequence stops just because we get to 0. We have to carry on into our negative numbers. Make sure you're happy with those before you move on. Okay, this time then, if we're given a sequence, we can work out the next numbers and the rule. So if we were given the sequence 5, 7, 9, 11, and we want to carry on, the next 5 will be 13, 15, 17, 19 and 21. And the rule is that we're adding 2. So we look to see, well, how do we get from one number to the next? We carry that on for the next 5 numbers, and then we're going to write down what the rule is at the end. So again, pause the video, have a go with those. Make sure you write down the first 4, continue the next 5 and write down the rule that you've used to continue that sequence. Pause the video, have a go now. Okay, so for our first one then, we've got 20, 24, 28, 32 and 36. And the rule for those, we added 4 each time. So you can write it as plus 4 or you can use the word add or the word plus, whatever you like. For the next one then, it continues with 25, 30, 35, 40 and 45. and we are adding 5 each time. So they're both ascending. Now we've got a descending one. It's going down in numbers. So 92, 90, 88, 86 and 84. And this time we're subtracting 2. Another descending sequence. So this time we've got 18, 15, 12, 9 and 6. And we're subtracting 3 each time. And our last one's ascending, but hopefully we can see there's a difference between the numbers. This one's gone up by 1, this one's gone up by 2, this one's gone up by 4. So we can't be adding to it, but it's going up, so we must be multiplying. So we get 16, 32, 64, 128, 256, and we're multiplying by 2 each time. Check your answers. Well done if you got that last one. Okay, so now we're used to seeing the sequences. This time we've got a sequence, but we've got terms that are missing. So in our first one, we've got the first term of 6. We don't know the second term. Then we've got a 0, minus 3, and we don't know the last one. So first we've got to work out, well, what's happening between the terms that we can see. So it's useful to find 2 terms together and see how they change. So we've gone from 0 to minus 3. So to get from 0 to minus 3, we'd have to take away 3. So if we do that to get from 0 to minus 3, we can carry that on and do that again. And we can do minus 3, which gives us minus 6 there. And now that we know the rule is minus 3, if we go back to our first term and do 6 minus 3, we get 3, and we can just check 3 minus 3 would get us to 0. So by using 2 together, we can work out the rule, and then we can continue that rule and go back if we need to. So that's our first one. Now you'll notice in B, we don't have 2 together. So we've got 4, then something, then 6. So let's see, how can we get from 4 to 6? Well, to get from 4 to 6, we could add 2. But there's a gap in the middle here, so that's halfway between. So half of adding 2 would be adding 1. Half of 2 is 1. So to get from 4 to the next number, we add 1. That gives us 5. And we can check that that would work. If we add 1, we do get 6. We now know the rule is adding 1, so we can continue the rest of the sequence. So 7 and 7 plus 1 is 8. So sometimes if we don't have 2 together, we need to find the difference between the 2 we have. And if there's just 1 missing in the middle, then that's half of that difference. For C then, so we've got nothing at the beginning this time. 4 something, minus 10, minus 17. So we have got 2 together we can use. To get from minus 10 to minus 17, we would have to take away 7. So we know the rule going from left to right is take away 7. So we can now go back to the 4 and we can take away 7. And that gives us minus 3. And again, we can check minus 3 minus 7 is minus 10. But how are we going to get the one at the beginning? Well, if going from left to right, we're subtracting 7. If I want to go the opposite direction, I need to do the opposite. So I need to add 7 instead. So 4 plus 7 is 11. And then we can check 11 minus 7 would give us 4. So if we want to go in the opposite direction, we need to do the opposite. Finally for D then, so we've got negatives and decimals this time. So again using 2 together to get from minus 3.2 to minus 2.3. You may need to use your calculator if you're not sure about that, but we're adding 0.9. So our left to right rule is adding 0.9. Minus 2.3 plus 0.9 is minus 1.4. We can check minus 1.4 plus 0.9 is minus 0.5, and we can do the same with minus 0.5. If we add 0.9, we get 0.4. Finally then, we need to fill in the one in front, so we're going to go from right to left, so we're going to need to do the opposite. Instead of adding 0.9, we're going to subtract 0.9. Minus 3.2 minus 0.9 is minus 4.1. It's quite a lot to take in there. If you need to, rewind and watch that bit again. Okay, so now it's your turn. So we've got 3 problem-solving questions for you to work with. So question 1 is about spending some money. So think about how you can set this out as a sequence. Problem 2, you've got some of the missing values to fill in. So again, we've just looked at how to find those by finding how one term moves to another, or if there's a gap, then we find half the distance. And problem 3 is using it to help with the science experiment. So it's given you a hint there that you might want to draw a table to help you if you feel that you need to. Okay, pause the video, have a go with those. Okay, let's have a look at the solutions then. So for the first one, so we've got £450 and he's spending £50 every month. So £450 then. So after 1 month spending £50, he would have £400 left. After 2 months spending another £50, we have £350. Another month, £300, and after 4 months, £250. For part B, we wanted to know how long it would be before the account is empty. So we can continue the sequence. So we can see 5 months is 200, 6 months is 150, 7 months is 100, 8 months is 50, and at 9 months it's 0. So the account would be empty after 9 months. Okay, question number 2 then. So those are the answers there for the missing values. So just pause the video and work your way through those answers there. And finally then, for the last one, so you could draw a table or you can make a list. So at 0 minutes there was 1 cell. It said the number of cells doubles every 20 minutes. So after 20 minutes there'll be 2 cells. Another 20 minutes, which gives us 40 minutes. There would be 4 cells. And part B, we wanted to know when there'll be 16. So if we carry on, adding on 20 minutes, then 60 minutes will be 8 cells. And 20 minutes more, 80 minutes, we would get 16 cells. So there'll be 16 cells after 80 minutes. Okay, that's it for today then. Next lesson, we're going to have a look at pattern sequences.